Welcome to my YouTube channel, Engineering Physics by Dr. Deepak. Today we'll discuss about the fundamentals of laser. What is a laser? Laser is a light amplification by stimulated emission of radiations, where stimulated emission is the principle of laser action. What are the properties of laser? Laser is a monochromatic. Monochromatic means mono means single, chromatic means color. So it's a single color of light, whereas ordinary light is a combination of multi colors, unidirectional. Laser light travel along a single direction, whereas ordinary electric bulb or tube light, it spreads all over the direction. Coherent. If there are the more than the one wave, they having a same phase or zero phase and same frequency, that is known as coherent. In the other way, ordinary light, it's a combination of different colors. So they having a different frequency and a different phase. Narrow bandwidth. Narrow bandwidth means it considers a single frequency of laser light. High intensity. If we compare the 100 watt of electric bulb or 1 watt of a laser light, then 1 watt of a laser light is highly intense as compared to the 100 watt of electric bulb. So in the fundamentals of laser, induced absorption or spontaneous absorption, we understand with the concept of atomic model. This is the nucleus of an atom, and here they having a different energy levels. So when a photon of light strikes the electron in these energy levels, so this energy level we are considering here E1, and this is energy level E2. Photon of light strikes the electron in the energy level, or we can say that the ground state E1. They absorb the energy and go to the excited state E2. So for more clarity, you can see from this diagram, these are the energy level E1 and E2. N1 and N2 are the number of electrons in the ground state and excited state. We are using a photon of light having a suitable frequency, strikes in the electron of the ground state. Electron absorb the energy and they go to the excited state. So here we can represent this by an equation. This is the probability. It's a probable behavior. It doesn't mean at the same time all the electrons go to the excited state. No. So this is the probability. Probability 1, 2, 1 is the ground state and 2 is the excited state, which is equal to B1, 2. Here we are using the B and A. These are the Einstein coefficients, where B we are using the spontaneous or induced absorption or stimulated emission, and A coefficient we are using for the spontaneous emission. U nu is the energy density, that is the total energy of the system per unit volume. Then second is spontaneous emission. In the excited state, there is a very small time period. Electrons stay here for 10 to the power minus 8 seconds, and after releasing the energy, they come to the ground state. And that emission is known as spontaneous emission. We can represent this spontaneous emission with the equation P-21 is equal to A21. We are not required any external source of energy to lie the electron in the ground state. So that is a emission in frequency interval. Third is the stimulated emission. This is the principle of laser action. We can understand this concept with the help of diagram. Here, this is the situation when the spontaneous absorption takes place, electron in the excited state. Now, a suitable frequency of photon that strikes the electron in the excited state, and it induces these electron, and here you can see there is a multiplication of photon, and that process is known as stimulated emission. So from in this diagram, atomic diagram, you can see we are using a photon of light that strikes the electron in the excited state, and after that there is a multiplication of photon. That process is known as the stimulated emission. So in the term of equation, we are using here P double dash 21. Probability from state 2 to 1, excited state to the ground state, which is equal to B to 1. U nu, where we are using the external source of energy to induce the electron in the excited state, and the emitting of a photon, that energy which is in phase with the stimulated incident photon. This result in the appearance of one additional photon. This process is called stimulated or induced emission. So these are equations we are using in the next article, that in the Einstein coefficients A and B. Now we summarize these fundamentals. So there are the three processes can be summarized through this diagram. Number one, absorption. When a photon of light, that is a suitable frequency of light, strikes on the electron in the ground state, they absorb the energy and go to the excited state. That process is known as absorption. Second process, in the excited state, the time period of the electron is 10 to the power minus 8 seconds. They are in the unstable state, or their electrons are in the unstable in the excited state. They release the energy and come to the ground state by emitting a photon of light. That process is known as the spontaneous emission. In the third case, we are using a suitable frequency of light that strikes the electron in the excited state, and it induces that electron and emit another photon of light. So here you can see there are the two photons of light. So that process is known as the stimulated emission. So what is the total probability of emission of transition from the upper level 2 to the lower level 1 is given by P21 is equal to P dash. We are using in our equation dash, P dash, that is the spontaneous emission, P double dash, that is the stimulated emission. So here is the transition from the excited state, that is the 2, to the ground state 1. So this equation we can write P21 is equal to A21 plus B21 U nu. Thanks for watching. Please subscribe my YouTube channel. Thank you.